Now, this probably wins the prize for most pretentious title of a video that I've made thus far. Um, Rationalizing denominators of radical expressions. That basically means that, okay, in math, it's impolite to show up at a party like that. Okay? Or like this. It's like not wiping off your shoes. It's like wearing, I don't know, what do you call it, white shoes after Labor Day or something. It's just socially unacceptable to leave an equation looking like this. Or like this, or whatever. We don't like square roots in the bottom. That's why it says denominators. Means, you know, the bottom of a fraction. And then radical means something with a square root in it. So rationalizing just means getting the square root out of the bottom. Okay? So now for regular square roots and stuff like that, it's actually not so bad if it looks like this. If it looks like this, that's more work. I'm actually going to do a separate video on that entirely. So the idea is, if I say have a square root of 2 on the bottom, and I want to get rid of the square root of 2, just like I could do if I was, say, finding a common denominator for adding a fraction, right? If I had, you know, 1/2, and for some reason I want it to be something else, remember how I can multiply the top and the bottom by a certain number and get, say, 3/6, right? Now, by the same token, I can do that here, except instead of multiplying the top and the bottom by a 3, I'm going to multiply the top and the bottom by a square root of 2. Alright? Now, what that's going to do is it's going to give me a square root of 2 on the top, right? 1 times square root of 2. And then on the bottom, it's going to give me square root of 2 times the square root of 2, which you can say is a square root of 4, or you can hop straight over and say that that's going to be a 2 on the bottom. So it's actually preferable in math, and I kind of think I know why, but I don't think it's as big of a deal as some people do. We prefer this to this, okay? So this is pretty much what the purpose of this is here, is to get used to doing that. So if I have to say the square root of 1 of the square root of x, I'm going to multiply times the square root of x over the square root of x, and that will give me on the top the square root of x, and on the bottom, the square root of x squared will just be x. Got it? Okay. So let me do 1 over the square root of 3x, since I already had that one up. And again, I'm going to multiply the top and the bottom by root 3x. And I'd end up with root 3x over 3 times x. And those would be my answers there. Now, there's not always a 1 on top. I was just kind of doing that for funsies. So let me give you something a little bit more interesting, maybe. Let's say 3 over the square root of 5. Okay? So to a problem like this, again, you're just going to multiply the top and the bottom times the square root of 5. So on the top, you'll have 3 square root of 5. And on the bottom, you'll have 5 times root 5, which is just 5. Okay? Now these can get more interesting. I'll, in a minute, give you just a couple of problems to solve independently. But let me introduce you one more concept, and that's the idea of what happens if you don't have a square root, you know, because you can always have like a cube root. So let's say I have a cube root of x. I'll just put it under 1 again because it's easier. Okay, now, if I want to multiply by something, if I just multiply by the cube root of x, then on the bottom, well, on the top I'm going to have this, but on the bottom I'm going to have the cube root of x squared. Well, that doesn't do me any good, right? I don't need the cube root of x squared. What I want is the cube root of x cubed, right? The cube root of x cubed will come out to be x. 3 divided by 3 is 1. So what you need to do when you don't have square roots is you want to multiply by something that's going to get you up to the right level to get rid of the thing on the bottom, and to get rid of the root sign. So in this case, rather than multiplying by the cube root of x, I want to multiply by the cube root of x squared. Okay? Now by doing that, the top doesn't change, but on the bottom, I've got the cube root of x times x squared, which is x cubed. The cube root of x cubed is simply x. Okay, so the idea is I'm going to say this again, I want 1 plus 2 to equal that 3. Okay, and that's really all there is to it. I say all there is to it because it still takes brain power, but if you can match the pattern, you're in good shape. So likewise, if I had already had a squared on the bottom, I have to multiply the top and the bottom by a cube root, but this time instead of by x to the first, or x squared, I'm going to multiply by x to the first. Because I want the 2 here plus the 1 to equal that 3. Because I can say that the cube root of x cubed is x. That same kind of theory applies no matter what's, first of all, whatever's on the top actually matters not a bit. Like say I had x squared root 5. Okay? So think about what you want to multiply this by to get rid of the root 5 on the bottom. To be x is something. So think about it. I want 2 plus whatever this is to equal the 5, right? So I would use a 3. Right? Makes sense-ish, kind of. So that's going to stay the same. It's kind of weird. But here on the bottom, I have the 5th root of x to the 5th, which is going to be the 5th root of, come here. There we go. The 5th root of, whatever that is. The 5th root of 5. Sorry, got distracted. The 5th root of 5, which is just x. Okay? So that's the general strategy you're going to follow. A couple of other things that are good to remember is the fact that if I have 2 things that are rooted like this, remember that that's the same thing as this. So since I wrote it, let's just work this one. So I'm going to multiply the top and the bottom by, now this is just a regular square root, so square root of 3y. So on the top I have 3 times x times y, and on the bottom, the square root of 3y quantity squared is going to be 3y. Okay? So I'm going to throw some of these up here for you, and then you can have some fun with them. Okay, so here's a bunch of problems for you to look at, so go see if you can figure these out. They're all a little different. This one in particular, right here, you're going to want to do some simplification before, in fact on this one as well, you'll want to do some simplification before you just start multiplying arbitrarily. Okay, so pause the video, go try to work these out, and we'll meet back here in 5 or 20 or never again, whatever you want. I'm cool with it.
So let's give this one a shot. So we see that we have the rational, irrational on the bottom, and that's square root of 2. So we want to multiply both the top and the bottom by the square root of 2. So when we do that, on the top we get root 5 times root 2. On the bottom we get root 2 times root 2, which is just 2. Now we can make this simpler because we can pull those two, the 5 and the 2, into the same radical. And so that gives us the square root of 10 over 2, and we just leave it like that.
Again, I would, even though I hadn't said this, I would probably go ahead and simplify some of this. So the square root of 16 is 4. For the square root of 9x, I can pull the 3 out, right, because the square root of 9 is 3. Square root of x, so 8 over 3 root x. Now I can go in and multiply the top and the bottom by the square root of x. So I'll end up with 8 square root of x over 3 times x. All kinds of excitement. Now this guy here, first step is to go ahead and redraw this. Alright, now you may or may not realize it, the cube root of 1 is just going to be 1, right? Because 1 cubed is 1. So the cube root of 1 is 1. So it actually makes this much prettier. Okay? Now we didn't work one like this explicitly together, but it's the same idea. I have 1 here. So I want to take the cube root of 2 to the 2. right? 2 to the 2. Okay, so now on the top, I have 2 to the 2. And on the bottom, the cubed root of 2 cubed, which is just 2. I can go ahead and rewrite it like this. Alright. Resist the urge to do anything weird here. You can't. This is totally inside its own root sign. You can't touch it. It has nothing to do with that 2 anymore. You can't divide them. You can't pull it, whatever. Just leave this wonderful little answer the way it is. Next one. Alright. I'm going to go ahead and pull this out into 2 separate ones again. Square root of 9y over the square root of 2x. Not a whole lot I can do. Oh, yeah, I can actually. I can pull the 9 out. I'll do 3 square root of y times the square root of 2x. Now I can multiply the top and the bottom by the square root of 2x. And that gives me 3 square root of 2xy, because those are all in the square root sign. And then on the bottom, I've just got the 2x. And again, I can't do anything with these x's because one of them's in a square root sign and one of them isn't, so it's off limits. And that's my final answer. Yum. A couple more. Okay. This one I can actually simplify. The 4th root of 81. Remember that. What that was. 3 to the 4th is 3 times 3 times 3 times 3. 9 times 9 is 81. So since the 3 to the 4th is 81, the 4th root of 81 would have to be 3. 4th root. So that's 3 4th root of y squared. Okay. Now I'm going to go ahead and multiply the top and the bottom times the 4th root of y to the... Alright, so I've got y. I want 2 plus something to equal 4, so 2 plus 2 is 4. Right, so on the top, I've got, under the 4th root sign, I've got an x and a y squared. And on the bottom, I have a 3 and a 4th root of y to the 4th, which is just y. And that's as pretty as it gets. Alrighty. This one again, we can begin to simplify a little bit. So I have the cube root of z squared. Now the cube root of 27 is 3. Let me go ahead and actually write this out as 2 separate ones. I've got a reason for it. So this guy on the top stays the same. The cube root of 27 is 3. Now I have the cube root of x to the 5th. I can simplify this. Remember, it's 5 divided by 3 is 1, remainder 2. So I pull out 1, and there's 2 left over. Okay. So I'm just going to rewrite it over here a little bit so it's easier to see and multiply with it. So 3x cube root of x squared. Now I'm going to multiply it by a cube root. Cube root of x. Now I want 2 plus something to equal 3. So 2 plus 1, x to the first, or just x. So on the top, I've got a cube root, and under the cube root sign I have an x and a z. Oh, gosh, how did that happen? It's supposed to be a 2. So, and a z squared. Whew. And on the bottom, I have a 3 and an x, and then I have the cube root of x cubed, so I have another x here. So that x has to do with that. So now finally, I've got the cube root of x z squared all over 3x squared. I'm good to go.